Okay guys, this is my second video on trigonometric equations, and now we're going to go into problems that are slightly more challenging. And bear in mind that this is for students who are doing the GCSE further maths curriculum, not A levels, because A levels you need to know a lot more identities. It's considerably harder. You're going to be dealing with cosecant, secant, cot, and things like that. This is just going to be using the two basic ones of sine square plus cos square is 1 and tan is sine over cos. Anyway, so here we go. And if you've seen my first video on trigonometric equations, you're gonna know that I favor the cast circle. So when I say that, you should know what I'm talking about, and if you don't, then you should probably watch that video first. Right, that's my preamble. Let's get going. So I need to find x for all values of x between 0 and 360 degrees. So we're going to solve this. Okay, so what I'll do is what you'll do normally anyway, rearrange. So I'm going to bring that 2 on that side, and I'm going to say that sine x is equal to 3, take away 2. So sine x is equal to 1. Now for this one, I'm not even going to bother using my cast circle because, as you know, if you've ever drawn the sine graph before, you know that it only goes up to 1. So that's going to be 1. The lowest point or the minimum value is -1. And where does this 1 occur? Well, it occurs at 90 degrees here. So the value of x that's going to give me 1 is 90 degrees. So that one was easy to do. So that's going to be 90 degrees. If you want, you can go through the process of saying, well, x is equal to sine. Actually, I should do that in a different color. So you should go through a process, if you want to, of saying that x is equal to sine inverse of 1 in your calculator, and that will give you 90 degrees. Okay, so that's pretty much as simple as that is, and that's straightforward, and that's done. That's the only time it's going to happen between 0 and 360 degrees there. So that's going to be your 360 here. Okay, all right, that was a quick one. Let's do a different problem. Okay, so here's our next problem. I think I should probably make a quick correction here and put this as a minus. Okay, so let's go for it then. We'll start by removing this -3, bringing it over there. So we're going to have that tan square x is equal to 3. And then we remove the square by square rooting. So tan x is going to be the square root of 3. But you need to bear in mind that when you started this problem, you started it as a quadratic. So you'd expect to have plus or minus there, because you're going to need to produce then four possibilities of answers for this. Okay, so if this was a quadratic, it probably would have been something like, I don't know, x squared minus 3 is equal to 0. So you would have a plus or minus for that. Okay, so that's why we need a plus or minus for the square root here. Okay, let's go for it then. I'm going to use my cast circle. If you want, and you've seen my first video, you can use the tan graph if you want, but I like using my cast circle. So I'll draw my cast circle, C-A-S-T there, and let's separate this. So this tan x is equal to root 3, or tan x is minus root 3. Okay, so we separated it now, and then we're going to look for our answers. So x then first is going to be tan inverse of root 3. Okay, So once we find our tan inverse of root 3, then that makes life pretty much easy for us from here on in. This is going to give us 60 degrees. And this 60 degrees is here in my first quadrant. I'm happy with that because tan of an angle gives me a positive answer, and tan is positive in the first and the fourth quadrant. And if you watch my first video, you'll know where I'm going with this. So this is my answer in the first quadrant. Sorry, as I meant to say third quadrant. And in this third quadrant now, we will do 180 plus 60 degrees there. So these two answers will be 60 degrees and 240 degrees. Okay, now let's deal with this one over here. I want all the values of the angle x that gives me a negative answer. Well, tan will be negative in the second and the fourth quadrant. Okay, so in the second quadrant, I will do 180 take away. So for this one, x is going to be 180 take away 60 degrees. And where did I get that 60 from? Well, if you watched my first video again, you will know that I like finding it in the positive first quadrant first and then reflect it to the quadrants that I really need. So I need it in the second quadrant, 180 take away 60, and in the fourth quadrant it will be 360 take away 60. So this gives me 120 degrees and 300 degrees. So finally, I can say, therefore, x is equal to, I like putting them in order, 60 degrees, then 120, then 240, then 300. All these values of x satisfies this equation here. Okay, and that's it. That one is done. Okay, 4 answers for that. Let's move on. So here we have a new problem, and this problem looks like a quadratic again. You can see here I've got 2 cos square x minus root 3 cos x is equal to 0. Well, don't worry too much about it. It's not too bad. I want all values of x between 0 and 360 again. So let's see what we really have. Let's factorize it. Now, what I want you to do is sort of see this in this way. If I change all my causes to, say, y's, I would have had 2y squared minus root 3y is equal to 0. That's if I change my causes to y's, okay? But the reason why I've done that is because I want you to see that when I say I'm going to factorize this, I'm going to take out the common factor. You can see the common factor here is y, isn't it? So the common factor here is cos x, okay? So I'm going to factorize it, and I'm going to bring cos x out. And in bracket, I will have 2 cos x minus root 3 is equal to 0. All right, so just the same way, if you were to factorize this, you take the y out, you'll have 2y in the brackets minus root 3, okay? Now, okay, let's carry on. So this and that bracket, they're multiplying and it's equal to 0. So I'm going to separate them now. So I'm going to say that either cos x is equal to 0 or 2 cos x minus root 3 is equal to 0. Okay? Now, we know this from solving a quadratic. This is what will happen. Once you've got two things multiplying and it's equal to 0, it either means that one of them is equal to 0. So it's either that one is equal to 0 or that one is equal to 0. And we work our way through that. Okay. Well, think about it. This first one here, cos of some angle is equal to 0. Well, you know from just generally looking at your cos graph, which I will draw a quick sketch of here, your cos graph, which looks like that, you know that cos is equal to 0 at, that's going to be 0, this is going to be 90, this is going to be 180, this is going to be 270, and then at the end we'll have 360 there. So cos is equal to 0 at 90 and 270. So straight away I know that the answers for these ones will be 90 and 270. Okay, so those two, that one is done. I don't even need to break a sweat on that. That one's done. Let's have a look over here now. Let's rearrange that. So what we'll start by doing is bringing this on that side. So we'll have 2 cos x is equal to root 3, becomes a positive root 3. And then last of all, we divide by 2. So cos x is root 3 over 2. And yeah, so now we're going to go and work through that. All right, so we should know now that x will be cos inverse of root 3 over 2, which is equal to 30 degrees. Now I'm just going to quickly draw my cast circle. So this is my cast circle here, C-A-S-T, and I know that cos of some angle gives me a positive answer, and I know that cos is positive in the first quadrant and in the fourth quadrant. So this 30 degrees that I've got, that's in the first quadrant. I'm happy with that. For the fourth quadrant, I will have to do 360 take away 30 degrees, which is 330 degrees. So finally then, let's put all the answers together. So my final answers then are x equal to, put them all in order, 30 degrees, then 90 degrees from over here, then 270 degrees, let's write that in, 270 degrees, and finally 330 degrees. And those are my final answers for x. So basically those answers satisfy this equation up here. And if you want to, put your calculator in degrees, you know, plug 30 degrees in there and see if you get 0. Plug 90, see if you get 0, and so on. Okay? Okay, let's move on. All right. If you want, you can pause this video and have a go at this one, but I'm just going to jump straight into it. So let's go. Looks like I have a quadratic again. There's a 2 on this side. I'll bring that 2 over. So I'll have that sine square x minus sine x minus 2 is equal to 0. Oh, definitely a quadratic of the order that we're accustomed seeing now. Okay, if I was to change all my signs to say x or y's, let's say y's, I will have y square minus y minus 2 is equal to 0. Okay, well, so that you can see that it's a quadratic. What I'm going to do now is I'm going to factorize that quadratic into something we're accustomed seeing. So we're going to have sine x and sine x there. And then I need 2 factors of that minus 2. I need 2 factors of minus 2. That's going to give me 1. So I will use minus 2 and plus 1. So one of them will have minus 2 and one of them will have plus 1. You should know how to factorize, so I'm not really going to go into too much detail about it, but that's it, it's factorized. And now, as I've done in the slide before, this means that either sine x minus 2 is equal to 0 or sine x plus 1 is equal to 0. Okay? Now, for this one, I want to show you something unique so that you're not tricked and wasting time. So I'm going to draw my sine graph again. I wouldn't need the cast circle for this one at all. Here is where I'm going to have a positive 1 and then minus 1 there. That's where the sine graph goes, okay? Now, let's go back to here and rearrange. So this is going to be sine x is equal to 2 when I bring the 2 over. Well, is sine x ever equal to 2? No, because 2 is further up here. So there's no angle in here that's going to bring sine x all the way to 2. So for this one here, there are no solutions. Okay, so no solutions on that one. Okay, now we put our attention over here. So sine x is equal to minus 1. Well, that we do know. I don't need to work that one out either. On my sine graph, that happens at 270 degrees. So it means that x is 270 degrees. And that's my only answer on this one, because they want all answers between 0 and 360. This one's come up with nothing because sine x doesn't go all the way to 2. And the only answer for minus 1 here is 270 degrees. Okay? All right. Here's our last problem now we're going to look at. And I've saved this one for last because this one will, cause us to work a little bit more. So here we go. First problem that you should notice is I've got causes there, then I've got a sine there. Who wants that fun? No one does. So it's better to have the same trig that we're using, the same circular function. So I'm going to get rid of this sine square and I'm going to change it to cos square. Now, if you've seen my video on trig identities, you should know that sine square x is 1 minus cos square x, okay? Or even if you didn't see my video, you should know it. Anyway, sine square x is equal to 1 minus cos square x. So I'm going to remove this sine square and put 1 minus cos square. So I'm dealing with only one suit. So here we go. Starting from over here now, we have cos square x plus cos x is equal to 1 minus cos square x. What I'm going to do now is I'll bring these on this side so that it looks more like a quadratic, and I'm going to merge them straight away. So when I bring this over, this will become 2 cos square x. I'm just going to skip that line, okay? If you want, you can write it out and do it slowly, but this will add with that and become 2 cos square x plus cos x, and once this 1 comes over, it becomes minus 1 equals to 0. Okay, so now we have a quadratic. We'll go straight ahead and factorize that. So I'll just pop that straight into my 2 brackets, equals 0. And this is going to be 2 cos x minus 1, and then cos x plus 1 is what we'll have. You can double check it and see if you multiply it out. 2 cos square x, 2 cos x, which will subtract to become just cos x, and then minus 1 times 1 is minus 1. Okay, so from this point, we know that either 2 cos x minus 1 is equal to 0, or cos x plus 1 is equal to 0. Let's focus our attention here first. I'll just jump ahead a bit. So I'm going to say cos x is equal to a half. If you want to know how I got it, bring the minus 1 over, it becomes a plus 1, and then divide by 2. Okay? So then x now becomes cos inverse over half. So we know that that's going to give us 60 degrees. I'm just going to quickly draw my cast circle over here. Stressing this about the cast circle, but it's really important that you get this. You can draw the graph, by the way, if you want, but like I said, I favor the cast circle. If I do the graphs, this video will just be too long. So my 60 degrees is in here, where I expect it to be, because cos of an angle is a positive answer, so I expect it to be there. My second answer, where cos of an angle will be positive, will be in the fourth quadrant, so that'll be 360, take away that 60. So my second answer is going to be 360 take away 60 degrees, which is equal to 300 degrees. So that one, I can leave that one there for now. Let's now focus our attention over here where cos x is 1, and we will say that cos x is minus 1 on this one. And for this one, for cos x being minus 1, I might actually turn my attention quickly to my cos graph, just to prove the point. You can see here that minus 1 will happen just there where there is 180 degrees. And I like proving this with the graph, because somebody is going to go try messing around with the circle and get that one wrong, which is not really sensible. So it's going to be there. I just label it quickly. So that's going to be 90, that's 180, that's 270, and then we're back to 360 at top there. So that we know the answer for this is x is going to be 180. That's where cos x will be minus 1. So then let's finish off then. So therefore our answers are x equal to 60 degrees, 180 degrees, and then 300 degrees. Okay, and that's pretty much it, guys. This is pretty much as difficult as it's going to get for you. Obviously, if you decide to do A-level maths, then it gets a bit worse than that. All right, so that's it for now. Hope this was pretty straightforward, and we'll catch you up on the next video. Any questions, please let me know.